Okay, hello, welcome. Hopefully you can hear me today. If you haven't noticed, we have a new microphone. So there might be a little bit of echo, but I think we'll work out the bugs in a couple lectures or so. So today I want to start out by talking about the assignments, because I had a lot of students ask me when stuff is due, how do they submit it, and I know we have a lot of new students, so I thought maybe I would run through this EMS and show you, and then go over the first assignment. Nothing has been due yet, and if you don't have a login to this system that you see on your screen here, it's different than the login that you would use for my website, so you have to contact the university. If you don't have it at this point, it's probably not a bad idea to start the process of getting one. It's your email address plus a password. They're supposed to automatically sign up new students, but usually it takes a couple weeks, so hopefully you have it at this point. This is the system that you're going to need to use to submit assignments. You cannot submit them on the bhacker.com. You have to submit them through here. And I have a student login that I'm going to use right now. And let me see if I can give you the student view of it. Let's see if this works. So I'm going to run through the login, show you the class. Oops, did this not work? Could you do me a favor and log in? Here, you type it in. Maybe I just typed it in wrong. Yeah, come around this way. Maybe. If you could log me in, that would be good. I probably had a typo in it. Yeah, it looks like I did. And let's not save the password because you probably don't want to. Okay, let's see if this works this time. Perfect. This is not my login, this is a student login, except for there's a little error up here, invalid. Oh, I don't know what that meant. Email or password, try again. And it was maybe, I don't know, maybe that's an error. If you click on course, well, this is interesting.
My portfolio.
I'm sorry?
My portfolio.
My portfolio. There we go.
Right.
I know, I was hovering the mouse over the tabs and they were disappearing on my screen, that's why. I know, I'm clicking on that. I'm waiting for the system. We may or may not, well, it looks like it's working. It's just running a little bit slow right now. Maybe the internet access is slow. Let's see. See, on my interface, I can click on courses, and it shows me the classes that I'm enrolled in, or that I have access to. But you're saying click on my portfolio? Yeah, click on courses. Oops. Okay, so it appears the system is running a bit slow right now. So hopefully we'll get in. If not, I'll try and pick a time when there's less activity going on the network and see if I can simulate. Oh, here we go. This is good. Okay, so if you actually I clicked on courses. I don't know why you wanted me to click on my portfolio. Normally I would click on courses. If you click on courses, you'll get a list of courses. I don't know if you're going to get all of them or if you're going to get the ones that you're supposed to be enrolled in. What I'm looking for is object-oriented design with Java, which is the class here. In fact, I'm just going to come up here and do a search and wait. I clicked on the search button and I'm waiting. I can probably think that maybe the network's running slow, and hopefully it's not the EMS system that's running this slowly. But we'll see. I didn't see OO design and Java on the list, so I have to search. Looks like the search is almost ready. Down here on the bottom, I see some status going on. So instead of plug and play, it's plug and wait, or click and wait. I actually went into that and I didn't see anything. Oh, let's see. I'll click on that. It also could be that the system is not working properly right now. Well, I don't think that little icon is working either right now. All right, so this was a good test of the EMS system. I was having more luck with the courses page. Let me see if I can just bring up the courses real quick here. I wanted to show you how to upload an assignment into the class. But it appears that either the system is down or not working properly, or the network speed is too slow. So let me get a second try real quick here. I see it is moving a little bit faster right now. Oh, here we go. We got something. I'm sorry? Yeah, that's somebody's profile. It's not mine. Education. So, where do you see the classes on here, though? Courses. All right. Sorry, is that your portfolio? Oh, okay. I just exposed it to the entire world. Okay. I am clicking on the courses link, by the way. If this happens to you, I don't know. I guess we got to figure out what's going on. So, of course, the day I want to demo this, it doesn't work properly. Okay, I think I'm going to abandon it at this point because it's not working properly. Unless you have it up on yours. And yours does come up. How come mine's not coming up? I don't know. Maybe I have to be patient. Oh, wait a little bit longer. I do see a status indicator on the bottom saying that it is trying to load. So I'll give it until that bar goes away. If it doesn't come up this time, I'm going to abandon it completely. So let's see. Yeah, we still have a few more minutes down here. I believe the TA sent out a how-to document as well. Yeah. Yeah, take a look at that how-to document. If you've received it via email, it'll show you instructions. I was hoping to demo it live for you. I'm still giving it 2 more minutes before I totally give up on this. And this is precisely why I have bhacker.com, by the way. Because technology doesn't always work. Okay, well, I think at this point it's wise to abandon ship and pick this up at another time, perhaps when the network's running. Because I'm impatient and I can't wait any longer on this. Okay, that was an attempt to show you the EMS. I'm going to minimize the screen. It might come up. Let me talk about assignment number 1. And again, you can get this from the bhacker.com website. You don't have to get it from the EMS system. And assignment number 1, you can actually do at this point. And I'm not setting a due date for it. What I'm trying to do is put you on sort of a schedule where I talk about an assignment, and then within the next week or so, it's not a bad idea to submit the assignment. Obviously, if you don't have an EMS login, you're not going to be able to submit it. Or if you experience what I just experienced and you can't get into the system, that may also pose an issue for you, which is why I'm not putting due dates on the assignments. But it doesn't mean nothing is due. I mean, it means that you probably want to start working on the assignments. All right, so let me talk about the first assignment. And it is in the course materials section on bhacker.com. And let me make this a little bigger so you can read it. What I want to do is tell you a little bit about the expectations and what it is you need to complete, what it is you need to turn in terms of the concepts that are being covered here. We already know how to create an object. We learned that in lecture 1 and 2. So you're going to create a class, and the class, what you're basically doing is you're writing a temperature class. And the temperature class is going to have 2 fields. The word fields could mean data members. If you're not familiar with the terminology, the lecture actually calls them fields. I call them data members, but this is the equivalent. Or variable. So you're going to have 2 variables. A temperature value that's going to be a floating point. And I haven't really seen that one yet in the lectures, but the data type you want to look for is float, F-L-O-A-T. That's what that's talking about. If you want to use a double, you can also use a double for that, but a float would probably make more sense. It's more common. And you're going to have another variable that's going to be a character, a C-H-A-R, character, variable type, and it's going to represent the scale. So it's going to be either a C or it's going to be an F for Celsius or Fahrenheit. Because this class that we're going to create is going to give us the temperature in Celsius or Fahrenheit. So it's a pretty basic thing. So make sure the 2 fields can only, and I have put only in bold, I'm not bold, in capital letters here, only be accessed through the accessor methods outside of the class. So what does that mean? Take a wild guess. Private, yeah. So make those data members private is what this is saying. And I'm going over this assignment in a lot of detail actually right now, so it's not a bad idea to take some notes because I'm giving you the answers essentially. So if you follow, if you write down what I'm saying, you don't understand, you're brand new to Java, you should probably still be able to do this, no problem actually. So yes, so in order to make those 2 fields only accessible via the accessor method, the accessor methods is what I talked about with set and get, to access or to get or to set, to create variable information. And those are going to be methods that you're going to create inside of the class. So you have those 2 private variables. If you want to add more variables to this, you may, but at the minimum, you want to have those 2 that we just talked about. And then the next part is you'll have to demonstrate that you know what a constructor is. So you'll have to create a constructor, and you'll have to create more than one, actually. So you'll have a constructor. One is going to be the default, and you're going to have 3 other ones for a total of 4 constructors. So 1 for each instance field. Assume 0 degrees if no value is specified for Celsius, if no value is specified. Celsius, if no value for the scale, is not specified. And then 1 with 2 parameters for the 2 instances variables and a default constructor. So if you don't understand that, if you give me more than 1 constructor, I'm not going to be that picky. What I want you to do is come up with, setting 1 variable, setting 2 variables, setting no variables, setting all of the variables, and all at once, which is basically 4 different combinations if you think about it. However, you are allowed to make slight modifications to this as well if you want to. I mean, you can actually set the defaults differently. The idea is to create the constructors. So the next part of the assignment actually has you create methods. So you might think, well, constructors are methods, but per the assignment description, I've got them separated out. So constructors, 4 of them. Methods, additional methods. So you're going to do 3 types of methods that you're going to create. And they're all the same. They're functions. We looked at how to create a method. We've already seen that, actually. So 2 methods to return the temperature. So those are going to be accessors, essentially. 1 to return the degree in Celsius, the other to return the degrees in Fahrenheit. And we want to use 2 formulas to write the 2 methods. And here we got the conversion. It's obvious. I mean, if you've taken a chemistry course or any type of basic science, it's just a calculation that you're doing. Hopefully, I've given you the formulas. Hopefully, it won't be a problem for you. In fact, the symbols that are in here, like the plus symbol, the divide symbol, can be used in Java if you're having doubts on whether or not the multiplication is a cross, whether it's an asterisk. Pick up a Deedle and Deedle text. If you don't know that at this point, you're going to need a Deedle and Deedle text to how to program in Java. If you're not familiar with that, I've been giving it out to everyone who's asked me what's a basic text we can use for this course? Because that he'll go through every one of the operators for everything. And so it's a great reference book if you're not familiar with it. And then you're going to have 3 methods to set the fields. So number 2 here, one of them to set the value, one of them to set the scale. So all of the functionality is pretty much going to be the same. You're going to be using the methods to set the data members, is what we've seen so far in those examples so far. And then we're going to do a comparison with 2 of the parameters. Both of the 2 parameters are objects of the temperature class. Maybe at different scales, maybe it might be of different scales, it might be Fahrenheit or Celsius. So the method should return an integer 0, 1, or -1. So you're going to have a comparison, and it's going to be, you can call the method anything you want. You can call it, in fact, you can call these anything you want. You don't have to go set scale, get scale. Although if you want to do that, it's probably not a bad exercise to reinforce the points of what it is you're doing. But if you want to say, create initial Celsius reading or something, you can call it that. So it's totally optional for you. And then comparison, and you can call that method anything you want as well. So don't get bogged down with what should I name this? What should I name that? Whatever you name the class doesn't matter either. You can name the class anything you want, as long as it matches the name of the file. And so you're going to do a comparison. 0 means that the 2 temperatures are equal, and you can read through the rest of it. 1 means that the first temperature is higher than the second one. So this is kind of gives you a small little exercise in error control, actually, and comparison checkings, which is kind of another kind of key component of programming. And then now for the driver program. So you're also going to need to write what I call a driver program, or you want to call it main program. If you want, you can put all of this in one file. If you've been following my examples, you may have noticed that I constantly say, oh, don't do it. Don't put it all in one file. And we're going to find out today why you don't want to do that. Because of inheritance, we have extra stuff hanging around we don't really need. But for the purposes of this first assignment, if you're brand new, put it all in one file. If you're not new and you want to do it correctly, use 2 files. So create the class for the temperature in a separate file, and then create my program. And call it assignment number 1 if you want. So follow whatever naming convention you'd like. You have flexibility. So what you're going to do is write the driver class. You can call it driver if you want. It does not have to be called driver. And it's going to contain a method, main method. And so the main method is what's going to run, essentially, the program. You can take information from the command line if you want, or you can have information hard set, hard coded, which means you're automatically getting information and you're essentially assigning stuff and mimicking it. Because what we want to do is exercise the class inside of the driver program. And in order to do that, you're going to have to make sure that you use each of the constructors. I know it seems kind of stupid, or not stupid, but redundant, I guess. But it's basically a test mechanism is what this is. And it's kind of a rudimentary kind of exercise to see you actually figure out how to run the constructor, how to call each one of them, and also test them. So how do you know it's going to work unless you run it anyway? So you're going to test each one of the constructors and each one of the methods except the comparison method, because there's 9 of them. If you think about the concept, you don't have to run all of them. After each object construction or field setting, immediately print out to the screen the values, and we've seen that already with the system out. And today I'm going to show you how to get input from the keyboard as well. In fact, I think I'll start out showing you that first, and then we'll move on to inheritance after that. And so design the driver program any way that you want. When you run the program, if you don't provide the parameters on the command line, and here's an example of how you could do it down here. Java space driver space 0.0C for Celsius, 32.0 Fahrenheit. You don't have to do it that way, though. You can hard set the data. In fact, you can do it in your main program if you wanted to. Create a new instance. Set the temperature at this, set the temperature. You don't have to ask for input from the user because it gets a little complicated when you start, and we'll see how to do it. And I'll show you how to do that today just in case you want to do it, but you don't have to, that's what I'm saying. In fact, all I'm really looking at is your class. So if your temperature class looks good, your driver program is making an attempt to run the temperature class, you're set, you'll get an A on it. You'll get 100%. A little hint down here, when from the command line, you're looking at strings. You can go ahead and read through this part. If you're an experienced Java programmer, then I would go and do it this way because it's easier. And you probably already know how to parse the command line arguments and see how many of them there are and kind of work with it from that level. I haven't really covered that yet in this class, so it's not required that you do it this way, is what I'm saying. So what do I need for you to submit? I don't need your .class file. I need your .java file. If you have two of them, which most of you probably will, you have to actually zip them together. What I was going to show you in the ITU database was that you can only submit, and this has been something that I've requested a change, but it hasn't occurred yet. You can only submit one file at a time per assignment. So most of you are going to go and you're going to open up the EMS and you're going to put your class file in there, your temperature, and then you're going to try to put the next one in there, and it's going to say, sorry, it's already submitted. And then that's why I wanted to show you the EMS today, actually. So if you're listening to this and you have already been warned, one file, only one file, and it can only be done once. You can't resubmit it after you've already submitted it. So my recommendation is to create a zip file that has both files inside of it, so you have one file. You can do a tar, a rar, a zip, any compression utility that's pretty common that you think the average computer science person can figure out. You can go ahead and use it. It will accept all different file types. Don't cut and paste it and put it into a Word document. A lot of people like to do that. The only problem with that is then I got to cut and paste it and put it back into text files if I want to run it or if I want to look at it. So it's better to give me the text files and to put them into one if you can. If you don't want to zip it, you can cut and paste and put both text files into one. This is why I said you can use one file if you want for this first assignment anyway. If you don't want to do it that way, you want to do them separate, put them together for the purposes of the submission. And then hopefully in the future we won't have this problem, so we'll be able to upload multiple files. But it's going to be a problem if you try and do it that way today. So, are there questions about this first assignment? And if you came in late, there's no due date set. But in terms of the way the course is progressing, we've covered all of the information for the first assignment already as of last week. And so it's something you probably want to start working on. So you can pace yourself throughout the course. Nothing is absolutely due until the very last day of the class, so it's not going to be counted late. So if you don't have an EMS login yet, you can't get in, like I couldn't get in a few minutes ago, don't panic, just save your work. Doesn't mean you can't start working. So go ahead and start on the assignments and then save them until you get access, until you can actually put them in. So if you do have questions about the assignment and you're too shy to ask right now, you can catch me after the class. You can also catch me by email message as well, and I can explain further. If you're brand new and you are having problems, you can send me your non-working source code, and depending upon how easy it is to fix, I might fix it for you. If it's completely off, I might send you in a different direction and say, hey, take a look at this website, or take a look at this other example. Because the first program is going to be a little bit hard for those who are just picking up Java, who don't have a Java background, because it assumes you know a lot about, well, if-then statements, or, while loops and stuff like that. It's going to assume that you have some basic Java programming background. So it's best to work out the kinks in the system and learn a lot on the first program, and then you can sail through the rest of them no problem. So, okay. So that is this first assignment, and just to preview the second one, what we're talking about next in the course, and what we're talking about today, is inheritance. So obviously the second assignment is going to deal with the inheritance concept. I'm going to wait until next week to go over that, but theoretically after the next 2 weeks you should be able to do assignment number 2 as well. So that's why it's probably not a bad idea to at least knock out in the first one, and then we can do the second one. So I created some new examples that I'd like to show you, and the new examples are not on the website yet. Okay, I hear some talking in the back, although I have a new microphone. Hopefully you guys can hear me back there, but the talking is still a distraction, by the way. So it's best not to talk if you can hold it back. I still hear the talking. That's okay. It's getting quieter as I start mentioning it. All right, so I created a bunch of examples, and the examples almost give too much information. So I haven't uploaded them yet to the bhacker.com website. But what I want to do is show you the examples today. And keep in mind, I will probably upload these in the next day or so. And these will be a significant help for you in both the first and the second assignment, actually. Because they're both dealing with creating classes, creating constructors, and then the second assignment using inheritance, essentially. So, but before I continue, I want to show you how to read information in from the keyboard. Because I've shown you how to actually put it out. I haven't shown you how to take it in. We looked at systemout.println. We looked at that as how to put something to the console. For the programs that you're writing in this course, it's DOS console applications or Linux console, which means we're not working with graphics yet. We will work with graphics later on in the course. I don't want you to create a graphical user interface to your Fahrenheit program because it would be a waste of time, actually, at this point. So what you're doing is you're either going to be taking information in or you're going to be just displaying it line by line. So in this particular program, and if you remember what I said about the import in the last couple lectures, I think it was just actually the last lecture, what we're doing is we're taking one of the I/O utilities, and we may or may not have to actually include that depending upon if you're using Eclipse, how you have your environment variables set. But as a general standard rule, you want to use the import Java I/O asterisk by default, because that gives you the system, the in and the out. It basically gives you the information that you need. This particular class that you're looking at, and I'll put this on the website so you see it, it's called read console, and it's in a file called readconsole.java. And it has a main void here, and it's doing a try, and it's doing a catch on an exception. And the try is essentially to say, watch out, listen for something. Listen for an event. The event that we want to get is information from the keyboard. So it's kind of I could have done a do while on this. Actually, there's a while in here as well. But and essentially what I've done is kind of created an exception handling, a little error checking. You don't have to actually put exception handling into your first program. It's not a requirement. There's nothing in that assignment description that I just read you that talks anything about doing exception handling. However, it's not a bad practice. Especially if you're brand new to Java, to start experimenting with that a little bit. But the interesting lines that we're what we're concerned with today to take a look at is how to get input. So we're using system.in instead of system.out, essentially. In the system.out, it's kind of simple. It's very straightforward, which is why I kind of just show you that first. And this is demonstrating a couple things. It's demonstrating the dot length on the string class, because what we're doing, let me separate this out a little bit. We could have we have a variable string s, the type of this variable s, the variable name is s, the type is string, and we're actually creating an instance of the object, of a string object, and we're running a method in here called length, and length is going to determine how many pieces are in the string, how many characters are in the string, essentially. We do this because what ends up happening is we have to read in the information from system in, put it into a buffer, and then take it out of the buffer. And depending upon what we want, we can take out 1 line, 2 line, 3 line, 1 string, 1 character. And so the input is actually more difficult than the output. Not impossible, but it's a little bit more tricky. Why they just didn't put a system.out, system.in.get everything. Well, there is actually kind of tweaks to it, but the more common way of looking at it is here. So what we're doing now is we're creating 2 objects. One is the input string reader that takes in and creates a new input string reader object. And this is an object, this is an instance of a class that's being created just like your other classes, just like everything that we're doing. And its constructor takes system.in. So it's taking it, creating an input stream reader object. And then we're taking the object and we're sending it to the buffer reader because it's buffered I/O that we're working with. And if we work with the buffered I/O, then we actually can read in more than one character at a time. There are other classes that we can actually use to read in character by character, but here we just want to take in it all of the input, put it into a buffer, and parse the buffer, essentially. We're not really, in this example, not really parsing the buffer. Instead, we're saying while the string is going to be equal to the read buffer, the buffer reader, BR variable that we created, read the whole line, and while it's not equal to an empty line, continue the program. So if you're brand new to Java, this might look familiar, the while. The do while and the while is the same as in any other programming language. So if you're familiar with C, it's the same kind of construct, which makes Java a really easy language to learn past the concepts, the object-oriented concepts, because the syntax is very similar to C. In fact, a lot of C programmers have a really easy time picking up the syntax because they can just use the same things they're already familiar with. In fact, all the variable types are pretty much the same as well. So here we have system.out.println. It's going to print out the length of how big is the string that we read in. So if we take a look at how this works, and I believe I put this in the inheritance directory. And I'm going to make this a little bigger here so you can see it. There is still some talking in the back I can hear. Okay, so I have, I'm not going to use Eclipse today because it's easier to show you the text files, I believe. They come out a little bigger on the screen. So I'm going to do that today. So I have read console.java. I'm going to compile it just to reiterate the point on how to compile. Read console. Oops. Of course I have to type, and that's not an easy task for me. Oh, there we go. And now I'm going to run it so you can kind of see what it does. If you're brand new to Java, you probably are going to want to do this, and I'll put this out on the website. I'll put it in I'll put it right next to the lecture for today, so you can kind of see it. If you have problems finding it, I can basically point you in the right direction for it as well. So the program doesn't do anything. It's waiting for me to actually, because I put that while loop in there, it's waiting for me to actually put something in there. So I'm going to put in, this is a test. So I'm reading again the whole line, actually. And it's saying 14. It got 14 characters is the length of this as a test. So it counts the spaces. Everything you type in is going to be counted. So what a lot of people do, actually, is they delimit it. And they'll look at it and go, well, look for this character while it's not a space, while it's not a comma. So you can use this to enter in your birthday, comma, date of birth, age, comma, first name, comma, last name. You can put it all in on one line, parse it in. And then what you're doing is you're taking that buffered information, running it through a loop, either a do while or some sort of a for loop, and saying, well, while you find this, copy it to this variable, copy it to that variable. Because what we're doing essentially is just copying this information to a string variable, and then we're running a dot length on it, and it's coming out with 14. So just test is 4 characters. So, and then if I put in the blank line, because of that condition I had in the loop, it's going to stop here because while it doesn't equal. And then this is an interesting thing as well. The comparison, you'll have to actually experiment with the comparison operators for your first program, because Fahrenheit's going to have you do a comparison between one and another. And so you'll have to figure out on strings, there are the dot equals, the not equals. There's all sorts of different ways of actually putting that together to do a string. Or you can say, is this one part of this one? Is that one part of that one? That's where the Deedle and Deedle book is actually going to come in handy if you're brand new to Java. So that was my little example on how to create input, to take input in. And as I showed you the output, I figured I should probably show you the input as well. All right, so let's move on to inheritance. We've seen how to create a class, and I'm calling this example inheritance 1. It's fairly basic. And let me make this as big as possible, actually. It's pretty big. There we go. All right, so this first part here we've already seen. It's and again, I didn't port anything in. I didn't create any packages. I'm kind of doing a little bit of review here for those of you who missed last week or the week before. But what we've got is a class, and it's called MyBase, and I've got one private. So this looks very similar to what you need to do actually for that first assignment, by the way. Integer x. I only have one variable, one data member. And this is my constructor with the same name. And I know it's a constructor because it has the same name as my class. And this particular one is taking on a parameter, so it's not a default constructor. If I had one that didn't take on any parameters, I could call it the default. But I'm taking on one, so when I create an instance of MyBase, I can actually give it an integer x, and then they can say this. We're using this. It would actually work if you said x is equal to x, but it's really bad practice actually to do that. Because when we say this.x, we're talking about this object's x, and this object's x is this private data member up here. So it's not a bad idea to get into the practice of using this, because then we'll start seeing how super works as well. And I think I showed you that last week as well. And then we have two. We have an accessor and a modifier. Well, actually, we just have an accessor. Sorry. We have the access. We can return x. So get x, and it returns x. And then we have a public show method. So we have two additional methods here. Then the public show is going to print out to the screen x is equal to x, whatever value we have in it. So it's the simplest class you can probably imagine. Here's the new part. So this is the base class. Let's say we want to, and this is our first inheritance example. So we want to inherit. Because the concept is we have an object, main object class, and then we have a hierarchy that we're building from it. And we can build a class that represents something. And then we can specialize the class into more classes as we go down. And everything that is part of the superclasses, the subclasses, is also a superclass. And I'll talk about that in a few minutes when I start the PowerPoint part of this. But I kind of want to show you the example first, give you something to think about in terms of how it looks. Because it's hard to tell what it looks like until you actually see it. I have some examples in the lecture, but they're kind of small. And it's kind of more, this is simpler than what's in the PowerPoint slide. So we're going to create our first derived class, and I'm going to call it myDerived. so here we go. And this happens to be in the same file. It does not have to be in the same file. In fact, it's odd that it's in the same file. Normally you'd see it in a different file. And because you can take this and you can say myDerived extends myBase. And good, you can see that's pretty big. Yeah, I'm standing right in front of you, so you're going to have a hard time saying it. So, keyword being extends. That is what gives us our inheritance, believe it or not, from a programming perspective. The word extends, that's all there is. Well, not really. I mean, that's how we create the class. However, there's a few fundamental characteristics, that properties that we kind of have to look at. Because once we start inheritance, then we kind of, what constructors trigger, what order they trigger in, what happens with this, and what if I want to override that? So those are the things I'm going to be talking about today. So what I've got here is the class myDerived, which extends myBase, and private integer y is in here, different one. Notice I didn't actually have to say anything about x. Up here we have private integer x that's in myBase. In myDerived, we inherit. Because we're extending myBase, we get everything that's in myBase in myDerived automatically. So it's very common. I see students reinvent the wheel. I'm like, why are you putting a private integer x in here? We have it. You have it already. That's one of the hardest things to actually kind of learn about in terms of what inheritance entails. So let's see. Now, actually, I probably could have put a little space here. This is our constructor. The constructor, again, has the same name as the class. So I'm not creating a constructor of x. I'm creating a constructor of, I'm not creating a constructor of myBase. I'm creating one that goes with myDerived. It's an addition to the myBase. Because remember, we got everything from myBase. So I have myDerived, which is taking on an x, which is the interesting thing, because x is not mentioned anywhere. I hear a banging. It's not mentioned anywhere in the particular my derived class. All right, and here's the most important part. Now, I talked about this a few minutes ago, and I said this dot x is equal to x in terms of assigning the variable. This is how we go backwards. Super x. Super is up, sub is down. It's actually kind of the exact opposite of what you'd think. So a superclass has a subclass, and a subclass can also be a superclass. So you can play multiple roles because one is going to extend off of the other, off of the other, off of the other. So the hierarchy actually gets built. When we want to go up a level, we say super because it's the superclass. And I'll get into the hierarchical stuff in a few minutes when I start the PowerPoint. But so that's how we get super x. Actually, we're saying bring in, give me super x, and then the derived super x. We're going to say this dot y because it's this is equal to y because we're setting this y and we're setting the super x that we have from our inherited class. Don't have to do it that way, but I did this just emphasize a particular point because what ends up happening is we have everything going on simultaneously. When we create a new instance of the object derived class, we get a new instance of the object base class as well at the same time. So, all right, so now we have a new method that says get y. We could create an instance and say get x from the superclass from the derived class. So yeah, I'm sorry, it's a little bit distracting, the noise. All right, so let me move along here. And so now we've got the show. This is interesting. Now the show is the same name as this show up here. How do you know which show to use? Good question. Good answer, actually, but different question. So, if you rewrite the method, you overwrite the previous method, and only the rewritten one is going to fire. If you have constructors with different numbers of parameters, you can use them all. You can create a new constructor that has a different parameter, and we see that here because we've got a constructor in that's taking on my derived is taking on an x and a y that is going to trigger. This one is going to be the constructor for my derived, which is going to trigger. And we're also going to trigger this other one as well. All of them, all of the constructors, unless we override them, are going to trigger if we're looking at a default constructor behavior, which means we're adding essentially to the list of available methods, which is how we extend the behavior and make things more complicated essentially for us. But so here we're actually doing what's called overriding. And we're overriding because we're using the same name as a method that occurred. We can also do something interesting. We can actually put something in the base, call it abstract, and not complete it. Because if you're thinking about, because some students at this point are thinking, well, if we can override it, what purpose does it serve in the base class if we're just going to override it? Well, good thought. Why write it if you have to write it again? So I'm going to show you how to use abstract as a key word. You put that in the base class, and then it's kind of like a placeholder. It says this exists, you need to implement the behavior, and if you don't implement it, the compiler comes back and gives you an error message and says, hey, you're missing this. So a lot of times what ends up happening is when you start making instances of classes, you actually have to make these dummy fake methods because the method, even though the method's not doing anything, it has to be there because it's abstract in the base class, and if you don't implement it, you're going to come out with, the compiler's going to complain essentially. All right, so now we have a system out. Now this new one shows both X and it shows Y a little bit more. And so now I put the driver program in here as well. This class is called Inheritance 1, and it's a basic standard. It's going to say my base B is equal to new base 2. So it's going to send X is going to be equal to 2. B.show, and then we're going to say my derived D, derived class, is going to be equal to a new derived with an X and a Y, and then show. So if I compile it, if I spelled that right, and I'll make this a little bigger here too. Let's make this bigger. Oops. Oh, the noise went away, that's good. Unless it just stopped working. So if I run it, you might get, you might expect the output. So it says x is equal to 2, because that's what b.show is saying, and then d.show is going to say x is equal to 3 and y is equal to 4. So it basically showed us how we overwrit the behavior in terms of the show in the derived class from the base class. And this is actually how simple inheritance is. So let's look at another example. And what we're looking at next is going to be a little bit, oops, actually I'm going to save this because I like the way I put the spaces in there. Cleaning up the examples while I'm talking to you. Let's see, what do we have here? Purple. So this one is inheritance number 2. And this one creates a class called purple. And we're going to have violet that extends purple. So we always know which one is going to be the which one is the inherited class because of the word extends. So, and I come back up here, I have protected integer I is equal to 0. Okay. And purple is running, and I is equal to that plus I is going to be equal to I. Essentially, it's going to show us the result. And then we have another constructor that takes on integer I. So this is kind of another review of the constructor concept. This dot I is equal to I. So if I see this in your first assignment, I'm going to be very happy. This is a very standard way of doing something. So follow this as an example of what you should do. And you don't have to put packages and stuff like that in that first assignment either. I forgot to mention that as well. And you don't have to use inheritance either. So system.out, okay, now we're going to print out purple I is running, I is equal to something. And now we're going to extend, and we're going to create violet that extends purple. So purple is a color, obviously. Violet is a kind of variation of purple, a little bit, kind of. I guess that's a good thing for Valentine's Day to talk about. Purple, violet, colors of Valentine's Day. All right, so violet just prints out, and violet I, the constructor, and this is kind of poor because I didn't put any data type or anything on there. I didn't actually, this is kind of sloppy. It's going to print out violet I. So we have the purple constructors and we have the violet constructors going on. And now what we're going to do here is we're going to create 2 violets. We have, and this is sloppy code again, but new violet 4. So we're running violet in terms of the driver program. Inheritance2.java. And it should be noted that this is really bad programming. The purple subclass is creating 2 objects, but it's not assigning it to anything. It kind of shows you can actually do that. Why do you do that? Because sometimes you want to create an object and pass it to some other object, or send it somewhere, or do something with it. In this particular example, we're just creating it, but we're not going to do anything with it. So I kind of did this on purpose to show you how normally people would actually create a variable out of it, assign it a value of that object, but I'm just basically demonstrating you don't have to, actually. And you can do this for purposes of shortcutting. But I would wait until you have a little bit more experience before you start doing it as a practice. All right, let me make this a little bigger so you can see the output of what happens. Note, we are making 2 violet instances. So we say Java inheritance 2. Where did the purple come from? All I made were 2 instances of 2 violets. One default and one sending it 4. Now I've got purple running I is equal to 0. Violet running purple. Basically what ends up happening is you've got the base and you've got the inherited class constructors firing off simultaneously. Actually, there's an order. One goes before the other. And I'll talk about that in a few minutes. Which is kind of an interesting instance of which essentially what you can do is separate out the functionality. So if you have X in the base and you have Y in the derived class, you can deal with X over here and not have to worry about it. it can be self-enclosing, it can be handled, and that functionality is still going to exist because every violet is also a purple object. So they're all the same. So you have two objects really instead of one that you actually created, but you only have one existing object for programming purposes. So you can't actually go back. Well, you can actually, and I'll show you that. Probably not today. I'll probably show you next week. You can actually come back and play around with the base inside of the inherited class and make some changes and do some things with that. So. All right, so I will make those available on the website as we get further. So let's take a look at the PowerPoint information. Let me just close this down a little bit. Can somebody tell me when it is 4:45? Can you tell me? I forgot to bring my watch today. I see the time right now, but I'm going, okay, good. 4:45 is when I'd like to stop though. All right, so this is lecture 4, and it is about extending classes. And I've prepped you with some examples, so hopefully this will make a little bit more sense. And I've on purpose kind of went through very slowly to kind of pinpoint out what the inheritance actually exists, or what it is entailing. So inheritance by definition, you can create new classes that are built on existing classes. This is your formal definition. Through using the extends keyword, and you're reusing the existing methods and fields, the data members and the methods. And you can also add new methods and fields, as we've seen, that didn't exist, and adapt the new class to new situations. That's what inheritance is about. If you notice it said extend and then one class name. We have what's called a single line inheritance, which means one class can only be built from one other class. It goes in a single line. So keep that in mind. Other languages actually have multiple line inheritance, but Java is a single line. C++ is also a single line. You can actually do some things where you implement something and then you extend something. So you can actually play around with it. You have a little bit more flexibility in other languages, but Java is pretty strict this way. So the terminology is a subclass and a superclass. As we've seen, the keyword super brings us up one level. So it's almost like you have to turn it around and look at it the other way around. Super is on top, but it's the base. And the sub is the extended class that you're creating, is the derived class. So it's this. So it's kind of interesting. Subclass and superclass have an is-a relationship. So an object of a subclass is an object of the superclass, as we've seen before. Then we have that purple and violet going on. They're both the same. They're one and the same, essentially. And here's one with person and student. And this example is what's being used and extending out. This is why I kind of wanted to show you those other examples. This one is kind of, let me zoom in a little bit, take a look at person for a few minutes. Person has a string name, and we have a constructor, name is equal to no name yet. We're setting that, it's going to have a default word. And we have another constructor that takes on the name. This.name is equal to the initial name. And then we have, and this should look familiar, actually. This is kind of like the last example I gave you. All classes are pretty much doing the same thing. I mean, they're all kind of looking alike after a while. One to get the name, one to set the name. So we could take name. And here I said set name, name is equal to new name. I didn't put the this in there. On the top here, on the constructor, I use this. So I'm just kind of showing you a couple of different ways of doing it. Then we have an extended class here. Student, it extends person. And we have student number. We already have the name because we have the name over here, string name. So we didn't put it in here. So in your assignment number 2, I don't want to see I don't want to see data members that are already included redefined, because Java won't tell you that. It will just go ahead and take it. And what you're doing is you're overriding it. You could essentially inherit a class and override everything. Why inherit? I mean, this is my point, essentially. Well, you do that when you don't understand the concepts. That's what ends up happening. All right, so we have students, constructor, super. We can use super in the extended class. We cannot use it in the base class if we did that. Well, actually, if we did that, it would go to object. And I'll show you the hierarchy in a few minutes, because we're going up one level. So our first class that we create always extends from object. So every class you've created so far extends from object, essentially. So we have super, we have the student numbers equal to 0. When we say super, that means go, give us the name, use the name. And here we have a new constructor that's going to take initial name, string, initial name, and student number, and super. So the way that we set, instead of using this dot, because this isn't this dot, initial name, we say super, call to super. This is actually kind of interesting because we're sending it initial name. We're saying this is the one we're talking about. Send it the initial name that we're getting. So it's kind of a shortcut kind of way of setting that variable in this particular constructor in this kind of format. And set the student number, get the student number, get the student number, void, set student number. The accessors and the modifiers, as we've kind of seen already. So here's the class hierarchy that I've been talking about. So every class is extended or inherited from another class, even your new class that you're not using. So if you actually can write the first assignment, you're using inheritance right there, because you're automatically inheriting from object. You're not doing it explicitly, you're basically inherently doing it. So whether or not it's declared to be or not is the point. So if a class does not declare or explicitly extend another class, it comes from object. And so here's the hierarchy. What we're looking at is object, person, and then student. And everything comes from object. So everything is an object, which is how you can use the class as an object. And we'll see that in the future lectures. We can actually send the class as an object, take a look at the object type, see what type it is, compare it with other objects. And you can actually play around with this on that first assignment as well when you do your comparisons. And I'll show you the function. There's a quick and easy function. It says, what object is it? What type am I? And then you can figure that out. So fields and methods in the extended class, an object is an extended class, contains two sets of variables and methods. Two sets. One, the field and methods that come locally from the extended class, and then you also get the fields and methods that are from the inherited or the super class, as we've seen so far. What are the fields for a student object in the previous example? Well, they're the name and the number, essentially student ID or student number. And so I have pointed out super already, but to give you the formal definition of these terms, why are you using them? The constructor of the extended class can invoke one of the superclasses constructors, one of them by using the super method. And if no super constructor is invoked explicitly, then the subclass's non-argument constructor is actually invoked automatically, as we've seen in the purple/violet example. So it's invoked automatically as the first statement of the extended class's constructor. And I had super actually I believe, in that example. So constructors are not methods and are not inherited, blah, if I can say that correctly. So that's why I say in the first assignment, create these constructors and then create these methods. Technically, a constructor is another method that you're writing, but it's not treated like a method, which is why it's nice to know the difference between the constructor and the methods, because they're treated differently. Constructors automatically fire, methods don't. Methods can be overridden. Actually, constructors, you don't really overwrite them, you just add to it. Because you can't overwrite a constructor. It's impossible to overwrite any constructor. You just add to it and modify it. You just select which constructor you actually want to go off to use it. So we have three phases of the object construction. So in the first part, without inheritance, we just made a new instance of an object, and we got it. So when the object is created with inheritance, we have memory that's allocated for all of the fields for the object, which is initially set by their default values. And it is then followed by the three phases of the construction. And here's basically what we're looking at in terms of how those constructors fire. It's important to actually, and this is kind of dry, but it's important to actually kind of consider this, because then you'll end up with side effect behavior. You go, why is that constructor still going on? What happened? Because what ends up happening is kind of interesting, actually, when you start using inheritance and you start creating objects. All of a sudden, funny things happen. And then your level of debugging and error checking is just ridiculous at that point, unless you understand the basics of what's going on. So you invoke a superclasses constructor first. And then you initialize the fields by using, and this happens automatically, by the way. You don't have to do this. All you have to do is create the instance of the object. Initialize the fields by using their initializer and initialization blocks. If that exists, I showed you the initializations. in the last lecture, it's not using a constructor. Instead, you're setting a block of code that's initializing. Anything that's outside of the methods or the constructors, you can put opening and closing brackets and put your initializing code. Not necessarily a good thing to do, but if you're not going to make it constructor behavior and you want it to initialize, that's the way you get around it, essentially. And if you're not familiar with that or you've missed the last lecture, it's in the last lecture 3. And then the invoked superclasses constructor is executed using the same 3 phases of the constructor. So it's processed recursively until the object has actually been reached. So it works backwards. It starts with the derived, goes back to the base, goes back to the base, goes back. Because if you think about the inheritance concept, we've only looked at two levels, a base and a derived. We can actually create a derived from a derived and a derived from a derived from a derived from a derived, and we go back recursively and execute all of those constructors, which may not necessarily be desirable. And hopefully, okay, you can see that. That's good. Let me make it a little bigger. Oh, that's good. Now we have class X, and this is really bad naming convention because it's kind of confusing to follow it with just one character names. But for simplicity, we have class X on the left, and on the right we have class Y that extends X. Okay. We have protected, and I'll talk about protected in a few minutes. So far we've just looked at private, public. We have integer, and that's again another X orig, is what the ORI stands for, like original X, is equal to 1. And then this is on the left-hand side, and then we have another protective, a which original. And then we have a constructor, sets it to the original X, so one variable is going to be equal to the other variable. And then on the derived class on the right-hand side, we see the class Y that extends X, and then we have the protected integer Y original, no X, just Y, equals 2. And then we have a constructor Y that's basically doing the same thing, setting which original to the Y. What's interesting, though, is to watch to see what happens in each one of the steps, and this demonstrates the triggering of all of the constructors that goes on. So initially, the fields are set to the default values, 0, 0, 0, 0, all the way across the board there, actually. And then in step number 1, and what I'm doing is I'm going through the steps here. Step number 1, Y constructor is invoked, so the derived class. So it's basically unfolding backwards. So Y goes off, sets everything, and then X goes off, sets everything, and then the object constructor is invoked. So then we're still at 0. We haven't actually set any values yet. And then we have the X field initialization. And then we have the X constructor that's executed, Y field in. So we're going back to object and then we're going forward, essentially. So we're springing back from object and we're going through all the different initializations. So it's kind of interesting to see how it's set and see how it works together. And nobody in their right mind sits there and maps all this stuff out. What ends up happening is you try to think about the logic when you have an error, when you notice that something is not being set correctly. Then what ends up happening is you got to go back, take a sheet of paper out, and go, okay, this got invoked, this got invoked. It's like figuring out the science behind everything that got invoked. And then you know, oh, I need to switch the order of that, or I need to get rid of that, or I need to change this, or I need to override that. So that's when overriding and changing comes into play. Because we don't have to deal with this. We can go ahead and modify the environment, make it customized for what we want. And if we're going to do that, then we're going to override. So overloading and overriding are actually two separate concepts. And by definition, what I'm talking about here in terms of overloading, providing more than one method with the same name with different parameter lists. We've seen overloading already. We've overloaded our constructors, actually. So overloading an inherited method means adding new methods with the same name and different signatures or different contents, if you want to call it that. So that's when we overload. We're not overwriting it. We're just adding, we're supplementing it, adding to it. And then overriding replaces it completely. So it replaces the superclass's implementation of a method with its own design. So that's how you can actually destroy inheritance completely. Taking a base class, you've overridden everything in the derived class, and why did you even have the base class is the point, because you've overridden everything. So you kind of want to minimize the overriding and you want to overload by theory, unless you want to totally change the behavior around, which gives you the option. So in terms of the overriding, both of the parameter lists and the return types must be exactly the same. So think about, the constructor. How do you override a constructor when you create another one? The same additional. And actually, Java will come back with an error message if you write two constructors that look identical, because within the same class. Because you can't. Why are you overriding within the same class? It'll come back and say duplicate method. Hey, it already exists. Only put it in there once, which is kind of not really an error if you think about it. But if you put that into subclass, you're replacing what's in the base class automatically. So it has to be the same in order for the compiler to find it and look at it. And if an overriding method is invoked on an object of a subclass, then it's the subclass's version of the method that gets implemented. So it's the current most, if you think about, Microsoft Word, when you save changes, it's the most current change that's actually going to be effective. So you can't go back and change your mind, essentially. And an overriding method can have different access specifiers from its superclass version, but only wider access is allowed, and this would be those access modifiers we looked at: the public, the private, protected. So we can make it more, we can give more freedom to it. We can't make it less restrictive. That's what we can't do. Because the hierarchy actually, in terms of the way inheritance works, it's a protective mechanism. And so a lot of the base classes are private, 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 private. Everything's private. Even the methods are private. And everything is done within the class to ensure that it can withstand somebody building on it. So the inherited class that comes in after it and gets extended from that object, it only has limited access to certain things. It can give more access, but it can't basically change the integrity of what's below it. And then this last time I'm going to save for next week, actually, the throws clause, because I'm not going to show you throws today, but I'll show you that next week. So overriding methods throws clause can have fewer types listed than the method of the superclass. I'll show you an example next week on that one. So accessibility and overriding. So this is when we get into the public, private, protective, a little bit of review. So I've given you public. Everybody knows public at this point. And why we use private? Well, we use private because we only want those variables changed inside of those methods that we're creating. We don't want the outside world to touch it, so it's private. Then we have protected. Protected is when we don't want the public to change it, but an inherited class can change it. If we make everything private, it's only within the class. And when we start using inheritance, as you've noticed with the violets and everything else, we want to add to it, and we want to change it, we want to do something with it. If it's private, we can't. If it's protected, then if we are an inherited class, we have access to it as if it were public. But the rest of the world doesn't. The main driver program doesn't. So private methods in the subclass, in the superclass cannot be overridden either. So private really does protect that base class in a lot of ways. So you can't override those particular methods. And that's actually a really good feature, because you don't want to change methods that should be there. If it belongs to a student or belongs to a person, it belongs to the person. We don't want this student acting like the person. We want to basically separate out the functionality so it's logically organized. If the subclass contains a method with the same signature, the same kind of format as one of the superclasses, these methods are totally unrelated. Which means, here's the next problem that students run into. Not only can I just take an override, make everything public in the base class, and override the class completely in the derived class, to the point where you don't even have to use, you can take out, extends, whatever, and you use the same functionality. But then what ends up happening is they got multiple methods with the same name, and which one are you talking about? And they're running multiple methods, because they've supplemented, they thought they were overriding, but they weren't overriding, because that was marked private. So now they have a duplicate. So you could actually run into a situation where you have a method here with this name and a method here with this name. Both of them work. You can call each one of them. So you're not overriding. So it's kind of tricky sometimes. The package methods in the superclass can be overridden in the subclass, can be overridden if the subclass is in the same package as the superclass. Then you can override. If it's in a different package, you can't touch it. It's separate. Protected, public methods always will be not as simple as it seems. Not as that simple as, okay, a little typo on the slide. Not as simple as it seems, essentially. Because and here's our example here. And hopefully, it's going to balloon. Let's see if I can make this a little bigger. So, we have on the top a sample classes, package P1 and package P2. Two different packages, which means we're not going to be able to override anything. Public class base. And we're importing, here we go, P1, because it's in package base, which is the same as if we imported java.io. Instead of coming out of the base class Java, it's coming out of P1 package, which kind of gives you another example of the package and how that works. And here we have base. We have base.pri. It's running system out. Actually, I really hate this example because it's kind of confusing with all the abbreviations. But essentially what we're looking at is creating two classes, a base and a concrete one, which extends base down here. And we're just printing out information. And what ends up happening is if we create a new instance here, C1 is a new concrete one. And we go C1.show, and the show is up here in the base that we're running. And it's showing us, it's going to run all four of the methods that we have specified here. And the four methods that we have specified are different in the base than they are in the extended, excuse me, the other way around, base extended. But the behavior is kind of interesting. And the behavior, if we run base.p1, base.pack, concrete pro, concrete publisher, we get, oops, let's see. Yep. Oh, actually, that's what's printing out. It's printing out the names. It's actually printing out. That's why the example's bad. I knew there was something wrong I didn't like about this example. Let me go back to the original one here. The show is actually printing out the names of the methods. And so when we created the new instance and we ran this show on it, it's printing out both because we're in two separate packages. So it's actually running both. So it's a bad example, actually. I don't like it. It's way too confusing. In fact, I think I'm going to skip this one too, because this is just an extension on it. So I'll revisit that with a better example that I'll put together outside of this slide set. So, all right, hiding fields, another topic. So fields cannot be overridden. They can only be hidden. What are fields? Data members. Another word for data members, or variables, as I mentioned earlier. So if a field is declared in a subclass and it has the same name as one in the superclass, then the field belongs to the superclass, cannot be accessed directly by its name anymore. So, because you've hidden it, essentially. It's out of view because it's out of context. So it's kind of another way of creating multiple variables, which you may or may not necessarily want, but occasionally you find a need to do that. So. All right, so let's talk about polymorphism for a few minutes. This is not going to be your entire, this is just a brief mention about polymorphism at this point. I mentioned it already in terms of the subclasses and the superclasses. Because we can have many methods that actually do different things. In fact, your Fahrenheit program could be polymorphic, if you think about it. A Fahrenheit Celsius temperature program. Because you can take on and hold a temperature value in Celsius, or hold it in Fahrenheit, and do the conversion back and forth. And basically that's a good example of what polymorphism is. It's basically being able to act like something else or change into something else. And we see that with variables, we see that with objects actually. We haven't seen it yet, but we'll see with object types that change. And this particular one is dealing with the inheritance part of it, meaning we can build in polymorphism into the concept and into the inheritance in terms of the way that we're designing the structure. So an object of a given class can have multiple forms, even as it's declared a class type, or has any subclass of it. So an object is an extended class that can be used whatever the original object is used. So the concept of inheritance is actually creating polymorphism in itself, because we're taking a person and turning it into a student. It's also a person, but now they're acting like a student. Or a violet that turned into a, purple that turned into violet. It transformed itself. So what we can do is actually kind of track the motion and track the level. And we can actually take and transform in different directions off the same object. So originally I said we have a single line inheritance. So let's say we have, going back to purple and violet, we have purple. I'm really bad with RGB colors, but I know we can make blue out of that, right? If we add yellow or something, I don't know. We add another color to it. So we have purple and we turned into violet. Well, we could take purple and turn it into blue, I guess, or what does purple turn into? I don't know. If you mix it, it's been years since I've played with watercolor colors, but you mix them together, and different combinations of the palette. There's like 4 different base colors. It's kind of like inheritance. Base colors turn into derived colors out of the base colors. The same way you played with watercolors and paint is what we're talking about in terms of the object-oriented polymorphism, because we're taking a base and we're turning it from purple to violet, from purple to blue, from purple to something else. Not everything is going to transform if you think about it. I mean, I know you can't make, black is easy. You can transform black out of everything. But I know you can't go to white, so it doesn't quite work that way. And then there's some paths that can't be taken, depending upon what colors you're putting together. But essentially that's what is happening with that purple and violet term. And it is actually termed polymorphism, actually, because it's changing, it's transforming. So in terms of a question here to ponder about, and the answer is right below it, so you don't have to worry about answering it. Given the fact that an object's actual class type may be different from its declared type, because the type can morph, actually. Then when a method accesses an object members which gets redefined in the subclass, then which member of the method refers to the subclass or the superclasses. So you have that, when you invoke the method through the object reference, the actual class of the object decides which one is going to be implemented, which one is going to be used. You can actually call back. You can morph backwards through the system and use previous characteristics or previous behaviors and not override them. So it's kind of an interesting kind of way to deal with it. And again, it's kind of a program by program thing. Because most of you are probably thinking about this going, this doesn't even sound like programming. When do I use this in a program? Well, it's interesting, actually. And in fact, the second assignment, you're going to create employees, or you're going to have people that are employees that are, some of them are teachers, some of them are staff. So they kind of transform and they warped into these different roles, but they're all derived out of one. It's a great way of actually setting the design of the program, because what you're doing is you're separating out functionality in terms of objects, which is the core of object-oriented design in a nutshell, actually. And so instead of taking modules, procedures, functions, you're creating objects. And the entire program is a series of objects that are built upon other objects. And even the language, even the core features of the language, it is basically done that way. That's the fashion of it. So. All right, so accessors of a field, declared type of the reference decides which one's going to be used. I'm going to skip this example because I really just don't like the examples that are in this lecture, but you can read through it and you can actually kind of see the methods that are invoked through the object references, and the object references are showing you here. We have super.show, or we have extended.show, essentially, but we've created a soup and an extended. So we have two objects of the two instances of two different objects, and we're running show on each one of the objects, but we're running it on the different objects. So if we haven't seen it yet, and I'm not going to show it to you for a few, but we can actually have an object that creates objects inside of itself. If you think about the concept of a linked list with nodes, you've got two objects that are working together. You have nodes, or sections on the tree, if you're familiar with the data structure. And the nodes are in the tree, in the linked list. So you have two structures that are working together. It's nothing more than two separate sets of objects. One object actually creates the other object when it adds a node, and then creates a link node to it. So it's kind of interesting how you can actually put that together and nest objects inside of objects. In that particular case, you can actually run methods inside of the different objects in the objects. So you can traverse through the whole tree, essentially, from the object level. Okay, so type compatibility is an object. An object is an object. Everybody's an object, but we're all different types of objects. And so Java is strongly typed language, very strongly typed. So if you try to do a compatibility check between different objects of different types, you're not going to. It's always going to come back false, actually. Objects of the same instances of the same objects will always come back true because they're all of the same object. And then you can also get true from bases when you do comparisons. If an object of a purple is also a violet, violet is also a purple, but purple is not a violet. So you can kind of see how the identity might work. So for compatibility, this is when we actually need this in terms of checking it. So when you assign a value to an expression, to a variable, the type of the expression must be compatible with the declared type of the variable. Obviously, same thing we have in C or C++, or we get a type mismatch error message that comes back. It's a slightly different error message in terms of how Java presents it. It must be the same type or the subtype of the declared type. So this applies to variables, it applies to objects. And then we have null, which is an object reference, is compatible with all reference types of the null. So we'll see some examples of that. In fact, the next time I show you an example, I'll put one together that uses null and that compares object types, which might be kind of interesting to see hands-on. So let's see, the types that are higher up, the type hierarchy. Oh no, there is a type hierarchy in the system. And it basically is determined on the amount of space that's being used resource-wise. Because what ends up happening when an object is created, it allocates, upon the instance of the object creation, allocates the space that's needed for the data members automatically. And once that's done, there's no more space available. So you can imagine, it's the same thing you get with C or C++, but you don't think about it the same way. You can make something smaller, you just can't make it bigger. So smaller means you're narrowing it because of the size. So think of it more along the lines of how much memory is the JVM reserving to actually store this particular variable, and then you're kind of then looking at the narrow or wide kind of concept. So the higher types in the hierarchy are said to be wider because they take up more space, and the lower ones are narrower, or less specific than the types that are below them, the lower ones down in the hierarchy. So when we have something that's less specific, we have narrow. So by concept. So similarly, lower types are said to be narrow, or more specific, more specific because they're narrow. If you think about the concept of the inheritance, and you think about, because, okay, this is kind of an interesting thing to actually kind of, we'll put this into perspective, hopefully. We built from base classes, from base classes, from base classes, this class built from this class. As we go down in the hierarchy, we get more specific. The more specific we get, the less information we actually have to put in there. Because this class is this class, which is this class, which is this. We get to the point where we're only changing one variable, and we're keeping everything else. So these take up less space. Higher ones take up more space. So essentially, that's basically how the hierarchy of those types are working. And believe it or not, all of the data types are in a hierarchy. So we have big ones, and we have small data type, which is sort of the same concept you get in other languages. I mean, you can take and create, an integer out of a double, no problem. But try to go from an integer to a double, so that's going to be a conversion issue, because the double is going to take up more space than the integer does. And the concept of the type is the same. I mean, you have an allowable range of values, and you have allowable operations that can be done on those particular variables. So widening conversions assign a subtype to a supertype, and can be checked at compile time. No actions needed, actually. Compile time will check and give you an error message if it can't be done. Otherwise, it's automatically converted for you. Narrowing converts a reference of a supertype into a reference of a subtype. So it goes the other way. and must be explicitly converted by using the cast operator. And do I have an example here? Here is an example, but let me cover one more thing first in terms of the rules. In a few minutes, I'll show you an example of how to cast these. But you're doing typecasting, but you're doing it on objects, essentially. So the types higher up the type hierarchy are said to be wider, less specific. Is this the same slide? Oh, it's the same slide. Okay, so I've already covered this. Oh, you know what? It's the same slide, but it's the same. It's two slides, but it's the same content. So let's skip right to the example because that's where I wanted to go anyway. All right, so let's see this work. Okay, so explicit typecasting. This is how we're looking at it. And you will have to do this because you'll have to turn something into an object. In terms of this first one here, what we have is an explicit typecasting, the type name within the parentheses. You can do this with integer, double, object. This particular example showing us object. Make it a little bigger. We have a string, str is the name of the string. It's going to be equal to test. And then we have object, object1 is going to be equal to take string and turn it into an object. So we explicitly typecast. In fact, this is, I think, the same method you use in C. I'm not a huge typecaster because it's not really good practice, but you see it more with objects because you've got to change the identity of the object in order to get the object to work with other objects sometimes. And so it ends up becoming an acceptable sort of thing to do in Java. And most C++ people will tell you, never typecast. Because they do it for comparison reasons, usually, because you've got a situation where you have to do something to translate this into this, and you have to convert it because it won't take it. You can't add it, or you can't do something with it. In object orientation, you actually have to do it so that all the objects can communicate within the hierarchy. So sometimes that actually becomes an issue when you want to use this object inside of this other object, then you have to typecast it. And you're doing it by explicitly saying object. You can actually put in the bottom here for narrowing the cast. It's provided it's really unsafe cast because you're expecting, you know, in terms of what you're doing, you're saying taking this string str1, this holding the it's a string variable holding the words test, creating an object, calling an object string1, and you're creating another one and you're converting the object to a string, and then you're taking the object and you're converting it to a double, which is kind of risky because depending upon how big it is, it may or may not fit. You almost have to kind of imagine that you're juggling memory. You're taking and you're reformatting a space. You can't make that space bigger than it already was to begin with. You can make it smaller, but you can't make it bigger. So essentially that's the concept behind whether it's safe or unsafe. If you got a big space, it's always safe. It's always safe because everything's going to fit. But if it's too small, you can't make it any bigger. It's better to start over again and change the design of the class, overwrite the information. So, all right, so if the compiler can tell the narrowing cast is incorrect, then at compile time, error will actually occur. Very rare, though, actually, that happens. In fact, depending upon the settings of your compiler, you might have this turned into a warning instead of an error. So sometimes you see warnings. Your program will compile correctly, but you'll see warning, you know, something about a casting or incompatibility or something. Don't ignore that because that will actually cause a side effect that's going to occur further down. So if the compiler can't tell at runtime, then it forgets it. So if the cast is incorrect, then the class cast exception will be thrown while the program is running, which is kind of interesting because if you don't put error checking in, what ends up happening is as the program's executing, then the runtime environment, the JVM, catches the exception, throws it. If there's no handling, as we've seen with the try and the catch, if there's no handling implemented, it'll actually just throw it to the screen. This will happen actually in examples where it's expecting a string and you've inputted a number, or actually more like a string into a number field. It'll throw an exception because it didn't get what it thought it was supposed to get. In some cases, that could cause a problem. And in this particular example, what we're looking at is where the red X's are were mix and matching types of objects. Because just because it's an object doesn't necessarily mean it can be used with another object, because you're going to end up with a type compatibility problem. So at the top, it found 17 incompatible types for person because we created this array up here and populated it out. So incompatibility types, and it just a couple of examples. When you found a person and you required a student. So we're taking, in these particular cases, I'm not going to go through all of them, but you can download the slice set, take a look at it, cut and paste it, put it into your compiler, and actually see it run. Or mix and matching a student with a person. And we're trying to add one to the other and work with an array of one, and we're giving it another. So it's not expecting what it's supposed to be getting. Or it's not getting what it's supposed to be expecting. So, long story short. So. All right, another note on the type conversion, type testing. So you can test an object's actual class type by using an instance of character. So this is how you can kind of figure out if an object is not, how do you know if the object is a student or if the object is a person? So you can say, is it an instance of, so if object is an instance of a string, then typecast it to the other one. So if you're a student, turn you into a person. If you're a person, turn you into a student, vice versa. So you can actually kind of work with objects correctly. And the instance of works with any object that you create on your own. It works with your classes, your objects. So. Okay, so before I mentioned the word abstract, and I said, well, if we're building a base class, and we know we're going to inherit from this base class, but we want to put some methods or some variables in there, but we don't want to assign any values. I'm getting close, right? Okay, no problem. I'm going to finish after this abstract concept because I already mentioned it. So we can create what's called abstract classes. And some methods are only declared. They're not filled in. Because it's kind of like, why do we want to reinvent the wheel all over again? And what this does is if you've kind of been following along with the logic, every time an object's created, memory is reserved. And the memory is in the runtime environment. So a lot of people use the abstract concept to conserve resources, to conserve memory, because the lower base classes, we don't want to allocate everything for that. We're going to allocate what's needed, and then we're going to build on it, and we're going to build on it, and it allows us not only to save time and energy, build the structure in there, build the format in there, but don't fill it in. And then have the base class be kind of generic, and then have the derived classes fill all the behavior in. That's how you really build a good hierarchy. Otherwise, then you end up with behavior in the base classes we've seen that you may not necessarily want, but it's there. So and this is another reason why as well that you separate things out into different files and you don't put the driver in one of your class files. Because what do you need with the driver stuff? When it makes a new instance of that class, you know, why are you going to put that in there? It's just wasted garbage that gets thrown out because you're really not using that class when you are building an inherited class from that base class. It's just extra garbage that's sitting. In fact, the program will run if you take and remove the .class file that the driver was supposed to be, and you just use the class. Because what ends up happening is even if you put everything, and I think I showed this to you already, you put everything all in one file, you get a separate .class file for every one of those classes that's inside of that file when you compile it. And when you send me your programs, don't send me your .class files. I don't really need them for anything. I can create them myself. In fact, we have to in order to see if your program actually works. So let me finish up with the abstract concept for today. And so some methods are only declared, so not concrete. No implementations are provided. They need to be implemented by the extended classes. And here we have person, we have an employee, and we have students. And this is actually kind of going along with the theme for the next assignment. So assignment number 2 deals with this concept of inheritance. So we have abstract class person. So we put the word, and it's lowercase, actually. It's not an uppercase, which provides you an error message, actually, when you start to compile it, which is interesting because Java is very case sensitive. Strongly typed and case sensitive, which makes it kind of difficult at times to work with. So we have class person, and in here we have protected string name, because we don't want the public changing it, but we want the extended classes. This class was built as a base for inheritance, essentially. And we have a public abstract string method, get description. We have a method, and we have a class here that's specified as abstract, which means that's all we have to put in here. That's our entire implementation. So base classes are generally small. really small, actually, and only the method names with abstract are used. Because if you leave one out in the inherited class, then you can go back, because probably some students actually at this point wonder why I put them in there at all, because we know we can just add whatever we want. But what if we know that we're gonna want this functionality and that you're gonna want to build on it? We can put the integrity into the base class and require that all of the extended classes have that method and implement that method. So we're kind of setting the rules for the inherited derived classes. If we leave it out, then we're making it's kind of sloppy because we're making it a free-for-all. I mean, we're not imposing any rules on any classes that are being inherited from us. We're just like letting anyone who wants to create anything from it, which people do, and it ends up becoming very sloppy in the end. So you can actually, if you're looking at somebody else's code and you have abstract stuff defined in the base, then you know, oh, okay, so it's supposed to be implemented, and you know how to look at stuff. Because it's easier to look at the top of the structure and then follow it down inheritance line than it is to go the other way around. And if it's not here, but it's here, it's more difficult to follow the logic and see where it extended from. So here we have class student that extends person, building this hierarchy over here. And it usually is a public string get description. So why put it here when you're just going to extend on it? And then we have a class employee that extends person. So this is another example showing you how we have two classes, two derived classes that are both inherited from the same base class. We can have as many as we want. So we have one, and we have branch can go out to infinity. Again, branch out to infinity, which is how you grow the class. Even though you can only go 1 to 1, you can have as many as you want at the same level. In fact, you can specialize out on each one of the branches as well. So this employee could be a teacher or staff. The student could be a CS student, an MBA student, could be different categories of students. So let me take a quick look here and see if this is a good stopping point. It might actually be. Let me finish up with this slide because this is the repeat of some of the stuff I already said, so I can probably summarize it quite easily. So each method that has no implementation in the abstract class must be declared as abstract. If you're not going to put a method body in there in the abstract class, you actually have to call it abstract. Any class with an abstract method must be declared abstract. So if we saw here, we have abstract class person with an abstract class method. If we have an abstract class method and you're going to run into this problem, the first time you start using it, you're going to have to go back and say, oh, the class has to be abstract as well. Otherwise, the compiler is going to come back and tell you that if you don't do it, because it won't compile for you. And when you extend an abstract class, two situations occur. Either you leave some of the abstract methods, be still undefined, or leave them undefined, include them, make them abstract. And if you do that, the subclass must declare them abstract as well, which is basically how you decide, well, you're going to require that I put this in my derived class, but I don't really want to fill it out. You're repeating the behavior. Just say, it's abstract again. It's abstract. We're not going to use it. So we have a feature, but we're not using it, essentially. But we include it same way as we did in the base, or define an implementation of it, a specialization of it, and actually provide the method body, and then you don't declare it abstract at that point. So you define a concrete implementation, and then it's no longer abstract. So abstract means, it's undefined almost, which is kind of another interesting interpretation of the word abstract. It's a higher level of detail. It's more broad. So say it's undefined, it's not specific. When you take it out of abstract mode, then you make it more specific. You define more behavior associated with it. So an object of an abstract class cannot be created. And it's actually, because you can't, there's no functionality in an abstract class. So if you end up with an abstract, you start using abstract on everything, and then you start in your driver program, because actually once students learn keywords, they start using it everywhere. You start using this everywhere. You start seeing public everywhere, abstract everywhere. And then how come the object can't be created? Because there's no such thing as an abstract object, because it's abstract. It's not defined. It's undefined. If you think about it in terms of the concept, so it can't be used. So note the declaration of the object variables of an abstract class is still allowed. So you can still declare the objects of the variable. Blah. But such a variable can only refer to an object of a non-abstract. So we have here person P is equal to new student. Ooh, well, because person's abstract, student isn't. So we can actually refer backwards to a student. So. All right, I'm going to leave you on this concept for today. That's a lot of stuff, actually, to think about. I'm not done with inheritance. There's actually more. Not too much more, but there are a few other little tricks to it. So next time I'll show you more examples on the inheritance. And maybe the EMS will work. So I can show you how to upload stuff, and I'll try that again next time. So we're done for today. Thank you for being quiet.